Okay, so I think there's no time like the present. Actually, I think I have a meeting at 3 o'clock that I have to get to. So I'm going to try to take you through as much as I can about what you should be studying and how to focus your studies over the next little while. It's not designed to be a killer exam. It's not designed to drop your average in any way. It's really just to give you an idea or how much of the lecture material you understood, how much of it you remember, and hopefully that will stay with you after this course is done. So we'll take you through as much as we can on the review session today. And the way I'm going to try to do it, and you can interrupt me at any time, I don't mind, is that I'm going to give you an overview of the midterm to make sure that we're all on the same page. Then I'm going to take you through week by week. So week 1, lectures 1 and 2, week 2, lectures 3 and 4, etc., etc. And I'm going to highlight the things that you should go back. And if you haven't studied them already, that's okay. I've kind of broken it down so that you can concentrate on those things as you go through them. There are a lot of notes, much more than you think are in there. And then at the very end, if there are any questions, whether online as you're listening, or if you had any that weren't answered, and if you had any remaining questions, I'll try to answer those as well. Does that work for everyone? And so most of the people here are kind of nodding their heads, but not really. Okay, so we'll just go through some things really quickly. It's only lectures 1 to 8, as I mentioned a few times. This is weeks 1 through 4, none of the tutorial material, 50 minutes. I've tried to write the exam so that when you finish, it takes you about half an hour to 35 minutes, giving you about 15 minutes to check over your answers and things. Some of the multiple choice, to be honest, are a little bit more challenging. Some are really straightforward, and I kind of balanced it out that way. But I think overall, it's about a 35 to 40-minute exam. So you should have about 15 to 10 minutes to look things over. Make sure that you are heading into the exam center and EX200. That's where we'll be writing. I'll be posting about that as well and talking to you about that on Monday's class. It's going to be written during class time, so again, make sure if you're coming from somewhere else to give yourself lots of time. 22 multiple choice test questions. I would say probably about 16 of them are pretty straightforward, and about 6 of them are a little bit more integrative, where you have to know your slides really well to be able to answer them. 3 short answer questions with parts, diagrams, etc., as I've mentioned before. Any questions about this before I get going? No? Okay, so week 1, lecture 1, most of this was actually just an overview lecture. There isn't really a lot that I'm going to be testing you on lecture 1. I don't want you to actually worry I'm going to be asking you about stuff before slide 21. So if you're going back over your notes, slide 21 is really where you should start paying a little bit more attention. It's where we talk about how you measure health, how you measure the body mass index, the waist to hip ratio, or WHR, as outlined here. You should start to know slide 22, and this is the classifications of being underweight, having a normal BMI, and again, we centered around 18.5 as being the ideal sort of body mass index on the lower end, and then goes all the way up to 24.9. And a body mass index of 25 is considered overweight. I told you not to concentrate on the other little details related to like the individual breakdowns within the categories, okay? The only thing I also mentioned about this one slide on slide 22 was that if you are under 18.5, you have a certain condition, and that condition is known as what? Do you remember? Cachexia, and that is sort of a wasting of your muscle tissue, and that's where you don't have a good body mass index. It's often a sign of cancer and other things where your body is wasting away. Okay, so please don't memorize values from slide 27 about how many calories are in specific foods, etc. Any questions from week 1, lecture 1? No, because yes. I'd say it's pretty good. To be honest, I'm not going to ask you, but I'd say for your own interest, yeah, it's not bad. Okay, so nothing else. We're going to skip right to lecture 2. So week 1, lecture 2. So this is a slide that I get asked a lot about. Like, what do we have to memorize on this slide? Do you guys remember going through this slide at all? many weeks ago. So the main point about this is that insulin receptors are on several different tissue types, like the liver cells or hepatocytes, as well as muscle. They form a dimer. When insulin binds, it sets off a signaling cascade, and it activates an intracellular tyrosine kinase domain, and this is a tyrosine phosphorylation event, which then recruits other molecules, which is very common in our course to take a look at. And this molecule IRS1 then activates PI3 kinase, and then I went through really quickly how PI3 kinase then activates AKT, and AKT causes the translocation of the intracellular GLUT4, the glucose transport molecule 4, to the cell surface. And without this molecule there, any glucose that's in the bloodstream bumping up against the cell actually has no way to get in. So we can't utilize glucose, even if we have lots of glucose in our blood, without insulin setting off this cascade and the GLUT4 translocation. I don't need you to memorize all these other details that are on this slide about the breakdown of the different lipid bilayer molecules. It's really the AKT activation of the GLUT4 and the GLUT4 translocation to the cell surface, which is what I emphasized in lecture, and that's how you should know it. I think that's how I emphasized it in lecture. I didn't take you through the whole biochemical cascade. So the same thing with this slide. I'm not asking you to memorize this slide at all. I think just knowing the general trend of the Paleolithic diet, where the sources of energy are taken from. So our modern diet is a lot heavier in terms of fat, also less in terms of fiber, and then in terms of protein, we don't have as much protein that's normally taken in compared to the Paleolithic, and that's really all I use this slide to set up for. I'm not looking to have you memorize useless facts on slides just to see how well you've paid attention to things that I actually haven't gone over in detail. Okay. Any questions about the first slide or the second slide? No? Having said that, this slide actually there are a couple of things that I wanted to point out, because you're going to get a question sort of related to this slide. And we talk about hunger, and we talk about the physiological influences of hunger, and we talked very briefly about things like having an empty stomach. We didn't really talk about gastric contractions. We mentioned ghrelin just in passing, but it's a good idea to kind of go through this slide and have an idea of what sorts of things influence our decisions to eat, which is what this slide was really there for. Like, why do you decide to eat? Sometimes it's physiological. Sometimes if you're with friends, you're more likely to eat, etc. So I would say this is a slide that you might want to go back and just review rather than try to memorize it, as some of the different factors that play a role in our decisions to start to eat. Physiological reasons, psychological reasons, as well as other influences after you've eaten. Now, this is one slide that I think all of you have an idea that you should know. And it is a pretty important slide, because this really sets the whole basis for metabolic syndrome. So we don't understand the genes that are associated with it. We know that there are issues with insulin. And in fact, in the animal model that I'll get back to in a few minutes, we know that there's a problem with insulin. There is unregulated glucose because the insulin's not working. GLUT4 translocation doesn't work. And we have lots and lots of insulin in the blood, lots and lots of glucose in the blood, which leads to hyperglycemia because there's no way for it to get inside the cells. We also know that there's a change in the fat deposition from just under your skin, or the subcutaneous fat shown here in yellow on the left, versus having fat inside your abdominal cavity packing your internal organs, and that's a bad form of fat. We also know that we can start to measure changes in obesity. Not just, this is more for metabolic syndrome, but in terms of obesity, where we deposit the fat is important. So as we accumulate more and more fat in the abdominal region here, the waist to hip ratio is going to change. And we know that we have to take into account the waist to hip ratio. And this is, again, down here on the bottom where it says more visceral fat. This does tend to accumulate more when you have this sort of apple shape versus sort of the pear shape. Okay. Any questions about this slide or what you need to know about this slide or anything else I've covered so far? Or anything I haven't covered yet that you just need some clarification, like how much detail do we need to know about a certain slide? Feel free to interrupt me at any time. Again, in terms of week 1, lecture 2, and these notes are posted for you. They're all available online. They're in the Blackboard page, so you don't have to worry about trying to get all of this down. In terms of lecture 2, slide 16 for using MRI, this is how we definitively diagnose whether or not you have metabolic syndrome. It tells us where the fat is being deposited. It doesn't tell us about the overall fat distribution. It tells us about where the fat is, unlike some of the other things that don't tell us about the overall fat distribution. So again, just keep this in mind that this is sort of the definitive diagnosis. Another really good measure of this is the DEXA scan. So you should make sure that you go over slides 18 to 19, which deal with measuring fat content. Some of it is very, very specific. Some of it is just like, what's your total body fat? It doesn't distinguish between having visceral fat versus subcutaneous fat. Slide 17 is a good one to go over as well because there's lots of data on this slide related to metabolic syndrome. So this is slide 21, and this is a slide that you should spend some time on. And in particular, you should know as your fat and as the adipocytes start to change when you are a lean individual on the left, to an obese individual, to a really obese individual, that there are a series of changes. So we have changes in the adipocytes. The adipocytes themselves get bigger at first, and what they start to secrete switches. It goes from this balance in the middle of, it goes from this balance of having anti-inflammatory adipokines, things like adiponectin, which we talk about, and then it becomes more like a pro-inflammatory adipokine, things that we've also talked about. So we know that they start secreting things like TNF-alpha. We talk about CCL2 several times in passing, that chemokine C ligand, and it changes. And the immune status of this also changes. And basically, it goes from being a good place to store fat to becoming an inflammatory or pro-inflammatory reservoir. So it makes you feel like you're inflamed. As it progresses, some of those adipocytes start to die, which is really the focus of what's here on the right. And you should make sure that you know the factors, especially the ones that I highlighted for you in class. You don't have to memorize this entire list. Again, I'm not a big fan of, if I didn't really talk about NAMPT at all, I'm not going to be asking you about this. But anything I've talked to you about in class is certainly something I would expect you to know. This is actually linked to the slide that follows this, which is slide 22, which goes into the highlights of what is shown here on slide 21. Okay, so this is a good slide for you to make sure that if you haven't started studying yet, this is actually a good slide for you to make sure that you go back over. And from week 1, this is like the one slide I'm going to ask you to spend time on. Any other questions about this? Yeah?
I have a question about, you said that this process is reversible, but...
Up to a certain point, yes.
So like, I know you said age is a major factor, but so does that mean that if we have full metabolic dysfunction at a younger age, we can still reverse it, or?
If you have metabolic dysfunction, it's possible for you to reverse it up to a certain point. There's a concept, if some of you take nutrition, and I'm not trying to make this into a nutrition course, what would that look like? So what would metabolic dysfunction look like? Physically, what would it look like? So this individual, their adipocytes are getting bigger, right? So what would happen to them? Most likely. Yeah, so they're going to gain weight. And one of the things that we know is these adipocytes, unless they start dying, actually don't disappear. Like, they stay there. And one of the things that happens is, have you heard of yo-yo dieting at all? So you lose weight, right? So you gain weight, you get more and more weight like this, and your weight goes up, and then you go on a diet and your weight comes down, right? So you can reverse this metabolic function. You can reverse some of this as well. But those adipocytes actually never go away. They stay there. And this is sort of outside of what we're talking about. One of the things that happens usually for most people is that once you start losing weight and you start eating again and you stop exercising, all that stuff that helped you for the first little while, like if this is time, the, the thing that makes this bad is that when you start gaining weight again, you actually gain more weight than when you started this dieting process. And this is why it's called a yo-yo diet, because you keep doing this, but at every point, you actually, that reversibility becomes less and less. That's one factor. And of course, you're also getting older, which is another factor. And after a while, it's not reversible. And so we know that actually just using like exercise is not enough for individuals that are stuck here. Okay, so that's really outside of what we wanted to talk about. I didn't talk about like the adipocytes sort of not being there. You actually have to eliminate them. You have to use liposuction, remove those adipocytes, maybe do gastric bypass, all that stuff. But okay. So in terms of lecture 3, as I'll show you at the very, very end, lecture 3 is one that you should spend lots of time on. So lecture 3, lecture 4, if you have not started studying it, those are the ones that you should be like spending the most amount of time on. Right? Do you agree? Sorry? Yeah, you definitely should. So you should make sure that you know the leptin pathway and how it works. And these are summarized for you on slides 7 through 10. Should also know the details because we switched and we said, look, here's one gene that's been implicated and the receptor for leptin has been implicated in obesity. We also know that on a separate chromosome on Prader-Willi, in Prader-Willi syndrome that we went through on slides 11 to 12, on a totally separate chromosome, not the same one that affects leptin, that we know that we can also get weight gain there as well. We don't know the reasons why, but we did talk about Prader-Willi as being a complex disorder. So going back to leptin, which seems to be involved in this, and on that last slide as I showed you, when you start undergoing metabolic dysfunction, leptin itself starts to become affected and its release from adipocytes gets affected as well. So you should know slides 13 to 14 involving the leptin receptor and how this activation causes transcriptional activation. So we get this dimer forming. This is the JAK-STAT pathway, this STAT2 dimer, STAT3 dimer of 2 molecules of STAT come into the nucleus, and then it will cause the transcription of various factors. And you don't have to bother memorizing this little box up here. It tells you how all of that occurs, but you don't have to worry about that. Any questions about this before I go on? Yes?
For the factors that get transcribed, like
Yeah.
I know we should know like POMC, but like there's others like TIM1 and then there's SOC3. Should we know?
I would say any of the bullet points that are there for you, then those are the ones that you should make sure that you know, but things that are hidden in a diagram like this, no.
And also debate all suppressing because I know POMC suppresses.
So I'll get to that in a few minutes, okay? Okay, any other questions about this before we go on? As I said, week 2, lecture 3 is actually a really, really big one in terms of stuff that you have to memorize. If you haven't started studying yet, or you think that you've gone and done enough studying, this is the one you should go back to. This is the one that you should be spending the most amount of time on. The other ones, like lecture 1, I would not spend as much time on it at all. And this gets into the next slide, slide 15, which is back to that adiponectin. So nice, normal, lean, healthy individuals with the different adipocytes, they release lots of this adiponectin. You should know some of the characteristic features of adiponectin. And then we go through different pathways in which adiponectin might be protective, especially in the heart. If we have a lot of adiponectin and it's directly working on the heart, it tends to be protective as well. And then in terms of slide 19, so 19, 20, and 21 are all really the same slide. 19, 20, and 21 are different variations of these slides down here. And 19 is really just the overview slide where everything is on that slide at the same time. And then 20 and 21 go through separate pathways. And again, I'm not trying to make this a neurophysiology course or anything else. I am going to ask you to make sure that you know the bullet points that are here up at the top for both. So this is uh, the orexigenic pathway or appetite stimulating. So anything that I put up there, like orexigenic means that you are enhancing feeding behavior. And if you haven't read that, and if you haven't understood what orexigenic is, you should make sure that you understand that by the time you get to the test. Like no one's going to tell you like, oh, this orexigenic factor is being released, what might it be? Your TA is not going to be translating that for you or giving you any hints on that. It makes sense that we also have an anorexic factor. So anorexia, most of you know, individuals don't eat. And if you want to think of it simply that way, make sure that you know the factors that are involved or associated with the anorexic. So it's really the major points that are up here. Above this diagram, you don't have to worry that you're going, you know, is there an M1C4, M1CR or a melanocortin type 1 receptor versus a type 4 receptor that's being produced? You don't really have to worry about that at all. Okay? It's really just what's up here on this particular diagram. One other thing that I'm going to point out to you, though, is that, and as your colleague Fong was mentioning earlier, there is also a link between the slides that I've shown you earlier with leptin, as well as neuropeptide Y, which are not on this slide in a lot of detail, and how they get released into the bloodstream. And you should link some of this back with melanocortin. And I'll just give that to you sort of as a little bit of a hint, so that you're not panicking during the actual midterm, and I'll come back to this on Monday as well. So take the time to study it, think a little bit about it. But this is all linked back to those slides related to melanocortin levels and this particular diagram. But I don't expect you to be able to draw this diagram out, nor do I expect you to be able to tell me about the different types of receptors. So this is not a good example of a diagram, label a diagram type, okay? As much as I'd like to, it's not a neuroscience class. Okay, so a couple of things. In lecture 3, again, lecture 3 is a really big one that you should spend lots of time on. So the drugs to concentrate on really are the ones that I sort of mentioned in passing here. So this is orlistat, which blocks lipase activity, so you reduce fat uptake, subitramine, and then the one down here at the bottom, phentermine. All of these are kind of related. Some are working on fat absorption, but the vast take-home message is all of these drugs have side effects. Most of them work on your brain in terms of either working like amphetamines or working on blocking cannabinoid receptors. And so these, most of them have effects directly on your brain. Outside of this one right here, orlistat, which is a pancreatic lipase or lipase inhibitor. Okay, so all of these other ones are really working in various ways on your brain. So uptake, reuptake inhibitors of neurotransmitters, catecholamines or other neurotransmitters, etc. And I think that was the major take-home message from that slide. And I think that's how I presented it to you at the same time, as well as them all having side effects. Okay, so don't bother memorizing all the different drugs. I would just be more familiar with them either working on blocking cannabinoid receptors or working on different neurotransmitter systems. The other thing that I'll mention in passing, slides 25 to 26, which are right at the tail end of lecture 3 that are repeated at the beginning of lecture 4, those are slides that you should make sure that you know. There are some details on there related to why we think BDNF might be important in food uptake, and those bullet points that are on there, that are about 4 on each slide, are important ones. Any questions from the end of week 2, lecture 3? Okay, let's go into, sorry, what's the question? No? So in terms of lecture 4, I'm going to tell you straight off the top in terms of just brute force knowing the material. Lecture slide to 9, in terms of multiple choice, yes. In terms of the text on slides 10 to 11, also a yes. You should make sure that you know them. If you've never encountered them before, it might be a little bit intimidating, but these are the types of slides. There's one more after this on the P75 low affinity receptor. Do you guys remember anything about that one? So these are all the TRAC receptors, TRAC A, B, and C. They bind to different neurotrophins like NGF. BDNF binds to the TRAC B receptor. And then there was one other one. Do you remember what that was? So that P75 low affinity, which of these different factors that are shown up here at the top, NGF, BDNF, NT4, 5, or NT3, bind to the P75 receptor? Do you agree? All of these 4 bind to the P75? How many of you studied week 4, lecture 4? No, not yet? It's next on your list, right? Yes. In fact, that's correct. All of them bind at low affinity to the P75. These bind at high affinity to each of these. So again, it's important to make sure that you know that. Make sure that you can summarize the data on slide 12. You should also go over slide 14 from this lecture, and I've used the PDF that's uploaded to your website to get these different page numbers or slide numbers. You should be able to summarize the data from that slide as well. And then from slide 15, you should be able to summarize how you would test for metabolic syndrome based on that one slide. And I'll leave this last little hint for you as well. So if you were to knock out a particular receptor subunit, like the P75, what sorts of protein changes do you see when you knock that one out? And that's the one scenario where I need you to remember specific details of an experiment. And that goes into the experiment that we're talking about in lecture 4. Okay, so in terms of lecture 4, other things to pay attention to, not just sort of the summary, when we knock out the P75 receptor, what sort of other protein changes occur in that mouse, but also in terms of lecture 4, what sorts of tests do they use when they look at the mice, and what are the summary of the results in the P75 knockout animal. And here's a little checklist for you. So I know that not all of you have finished studying lecture 4 yet. At the end of studying lecture 4, if you don't know what these things are, then you know you should go back and study lecture 4 again. I'm not going to mention them. Some of them are right in your notes. Some of them are not so easy to remember, I would say. For example, H89 and isoproterenol are actually bundled together. And they're related to slide 20, which is protein kinase A. Do you guys remember what protein kinase A is? You must remember from Bio 220. Sorry? Bio 230. Okay, Bio 230. So what is the protein kinase A activated by? So this is a cyclic AMP dependent kinase, which is protein kinase A. So we need lots and lots of cyclic AMP that gets activated through the activity of adenylate cyclase, and then it activates protein kinase A. So these two are involved in that pathway. And again, I talk about this being a tetramer, and you should make sure that you know the details on slide 20 related to pKa. And I'll leave that with you to go back and study, and then we'll come back on Monday after the break to make sure that you've picked up some of those details. Any questions related to this? Because we're moving on to week 3. Okay, I think we're doing okay for time. So week 3, in terms of week 3, lecture 5 is actually fairly short, so I would also spend a little bit less time on lecture 5 overall. You should be able to define at the end of studying for lecture 5 the microbiome as well as what microbiota are. The full definition is not just bacteria. Even though we've talked a lot about bacteria, it's not just bacteria, it's the viruses, bacteria, and eukaryotic organisms. You should know the bullet points on slide 8 for the different skin bacterial populations. You should know the major features, which means the secretions, where we find them, for all of the different glands that are found on slides 10 to 15. So like sebaceous glands, you should know what they are, miracrine glands, all of those. So here's a level of detail I would probably ask, because it's in your slides and we cover it a couple of times in slightly different ways. The P. acnes that we talk about in this lecture, when we talk about skin, before we move into the gut microbiome, do you guys remember what kind of bacteria it is? Is it a rod? Is it a causus? Is it gram-negative? Is it gram-positive? Remember you guys were saying that you would have gotten 50% if you wrote that now? Yeah, maybe. Okay. So I'll ask you to make sure that you know the types of bacteria that the P. acnes are. And in general, you should also know bacteroidetes as well as firmicutes are either gram-negative or gram-positive. And you should know the difference, to be honest. We didn't go through the gram stain, which is how we identify these different bacteria, but you should know if they're gram-negative or gram-positive. And it's actually in your notes, and make sure that you go back over your notes to do that. Sorry, are you have a question from the online people? Wait, who's online? Who is it? Joanne.
In lecture 4, for the tests done, do we need to know how many weeks/days for the tests example after 3 weeks on a high-fat diet?
No, it's okay. I believe that you read that correctly. Yeah, I think the reason why Joanne is asking that question is because what happens is on that test, when you knock out the P75 receptor, after 3 weeks, what we see going up is really only in the white adipose tissue. Everything else stays low. And then at 8 weeks, it actually comes back down. So in terms of timing, no. But you should know what compensation in the tissues. Like the timing is not so important. Okay, wow, that's interesting. I've never had someone ask a question once. Is it social media? Facebook, nice. Okay, so the other thing that I'm going to mention, there's not a lot from this lecture. There really isn't. So it's not one that you should be spending like an inordinate amount of time on. It's really lectures number 3 and 4 that you should be spending more time on. Lecture 5 in the big scheme of things, not so much. Okay, outside of what you need to know on here, if you study this and you know everything on this slide here for lecture 5, you'll be fine for lecture 5. That's it. Again, I don't want you to waste time, because I know you guys all have so much time to waste, right? You don't, so I don't want you to be doing that. So lecture 6 is another really big one. And for lecture 6, you should also be spending some time on this. So you should know the details of slide 7, which go through the major phyla in terms of bacteroidetes, firmicutes. You should know the overall concept of gastrointestinal colonization. So that's that one that some of you were drawing out by hand, where you see the esophagus, and then you see the stomach, and then you see the small intestine, large intestine. And we know that as we go deeper into the GI tract, that we get more complexity, more complexity. So you should know the different things related to gastrointestinal colonization. Okay, is this Joanne again? No.
Oh, Alana? Okay. What is the difference between phyla and genera?
we're not going to worry about it. Just whatever we mentioned in class, again, I kind of use those terms very, very broadly anyways. And to be honest, I'm not going to be testing you on the phyla genera of the different types of bacteria. So just as they are sort of in the notes. Do you guys still do that in your bio classes? Taxonomy? No? Yeah. Um, or maybe you do and you're just telling me no. I don't know. I trust you. I trust that you're being honest. I have no idea. I really haven't studied bio since I did Bio 110 way back in the day. And there we actually had to learn all the different genre, phyla, etc. So, okay, so in terms of slides 11 to 12, um, you should know the major concepts. You do not have to memorize the names of any researchers. I promise you, you won't get a question related to like which of the following researchers did this experiment. I don't like those types of questions. I find them pretty useless, to be quite honest. So just know the major ideas that are found on slides 11 to 12. And then you should know slide 13 for details. And this is slide 14. And along with what follows on slide 15, which are a few bullet points related to this slide, this is a slide that I've mentioned several times that you should know for your midterm. And you will definitely see all kinds of different things coming out of this one figure. Okay, so spend time on it. Make sure you know that there are differences between vaginal delivery and early colonization through the cesarean section versus vaginal delivery. The bacteria we start off with are quite different, and you should know the bacteria that we start out with. But after we start developing, that the colonization of the gut microbiome proceeds more or less on this sort of track that I show you here. You should know some of the different timelines that you see up here. And if you know this diagram well, like you'll get good marks on this section on your midterm. And you should expect more than one question, whether it's multiple choices or whether it's multiple choice and short answer coming out, you should expect to see this, okay? Slide 22, I'm just going to come flat out and tell you, you should expect a multiple choice test question from this slide based on what bullet points are there for you. Make sure that you go over it. There is a bacteria that is mentioned in terms of fat invulnerability in slides 19 to 21. So this is the idea. If the gut microbiome is so important and we can change the gut microbiome, how can we change it to our advantage? Some individuals went and used different bacteria like the Paracasei, and they suggested that at least in humans that it could result in being invulnerable to fat deposition. Again, it hasn't been reproduced, so we're not really sure if that's correct, but the theory is really nice. So from lecture 6, that's it. There are a few slides related to the gut firewall, but that's actually in the next lecture, which is lecture 7. And slide 7 to 8, you should know the details on the bullet points that are found on slide 7 to 8. And to be honest, I can't remember what slide 7 to 8 is. Slide 10 on fecal transplant. So we talk about host factors, genetic factors, physical factors. You should know those. There are like 4 different points on there on that slide, and you should know those. Again, remember, some of your answers are short answer questions. So what would change a fecal transplant? What factors might affect the fecal transplant? Well, there are host factors, there are genetic factors, there are physical factors, and you should know some of those. The next series of slides are actually related to germ-free mice. Oh, I know what slides 7 to 8 are. Slides 7 to 8 are actually this gut firewall. And you shouldn't worry about having to label a diagram because actually we tried a number of different figures, we tried working on different things, and it's really hard to photocopy it to make it a fair question. So in terms of knowing details on that, the bullet points are the most important ones on slide 7 to 8, which is the gut firewall, I think. You'll have to tell me if I'm wrong, but I think that's what I meant by that. You should know the differences that we find in the gut between a germ-free mouse and a regular mouse. on slides 13 to 14. Again, the bullet points being the major things, but even if you look at the pictures, I think it's fairly obvious. And in terms of the toll-like receptor system, I would worry more about sort of knowing what the toll-like receptor system is involved in, the signaling on the toll-like receptors, and then the toll-like receptor 5. And it's a lot of slides. You get one multiple choice on that. Isn't that terrible? But it's a really easy one if you've studied the toll-like receptor system and you know the toll-like receptor system. At the end of it, if I activate toll-like receptor X, what gets activated inside the cell? Do you know? Sorry? Well, in theory, you could, but that mid-88 is one of those, and then this leads to activation of NF-kappa B, and in turn, it could, in theory, turn on some of those cytokines. But knowing some of that will be important as well. And again, you have definitions. So simple definitions like what is a MAC, as we learned it in class, related to the carbohydrates, fibers, and everything else, is important as well. And how do you measure diversity? Do you guys remember? So we talk about the PC index as well as the Shannon index, and those are two measures that we can look at overall increases or decreases in diversity. So make sure you spend some time going over that. In terms of lecture 8, you get very little coverage on lecture 8. Slides 6 to 8 for content. Most of this should be really clear by now. Like after you've studied all these other lectures, most of that should be sort of common knowledge and relatively clear. And this should cover things like the bacteroidetes as well as the firmicutes. And this gets back into diversity using the Shannon index from, yes.
CD1103 plus CD11B plus and DCs are the dendritic cells?
Dendritic cells, yes.
Yes.
Sorry, what are we, was that a question or?
Yeah, that was a question.
Yeah, dendritic cells, yeah. So from lecture 8, you don't have to worry about anything from the end of that paper on the gut microbiome and fiber effects on the gut microbiome. So nothing on red meat or anything else. Okay. So it's not so bad. Oh, that's what you've been studying. Okay. Any other questions on this at all? So don't bother studying it. I promise you there are no questions related to the World Health Organization, classifications of red meat or anything else. So if you're going back and studying, this is what I would like you to try to do because I don't want you to waste your time. The questions that you're going to see more of in terms of content on the midterm are coming from lectures 3 and 4, both short answer, multiple choice. You get more coverage on 3 and 4 than anything else. You will get coverage from lecture 7 and 6 and then 5. So this is the order. If you're studying, like read through all your notes in chronological order just to make sure you get a good idea of where you've come from. And then when you're going for details, like this is the order. Like you get the most amount of questions from 3, most amount of questions from 4, lecture 7, 6, 5, and then it goes sort of 8, just because we cover a paper in here. And there's some data from a paper that you should make sure that you know, lecture 2, and then lecture 1. Okay, that's sort of the order I would study in if you're going for content memorization. So do you have any other questions about specific content or about the midterm? Are there any questions from people who are online, which is, if you can figure out what they're trying to ask?
No, it just got changed. So basically, nothing about red meat comes up on the midterm. Basically.
How about I let you guys answer that? Yes, there are lots of people saying nothing about red meat on the midterm, nothing. So the slides that cover that at the end of lecture 8, nothing. Any other questions? Okay. Oh, this is neat.
Oh no, it's okay.
Okay. Okay. Um, So here are a couple of slides. I heard that there were some issues where it wasn't posted for you or it didn't come through on the YouTube link. So these are it. So in terms of this type of question, you'll get exactly this question, then you'll get A, B, C, D underneath it. So you'll have to go back and study up on lactobacilli a little bit. Okay, and that gets back to those lecture sections that we had on the gut in terms of its colonization. So lactobacilli are there in the gut during colonization. It's usually there through vaginal delivery. And it's also there in terms of being found on your skin in some places as well. So go back, make sure that you know lactobacilli really well, and then you should be able to pick out the one answer that is incorrect if you've gone through and looked at lactobacilli. And then at the very end, again, I'm just going to leave that with you. You'll have to think a little bit about this. And actually, after today's sort of big overview review session, where do you think we actually talk about gut epithelium? Which lectures? Integrated, but in particular, where we talk about reducing the numbers of gut epithelial cells. Sorry? Lecture 8, a little bit. So it's really that gut micro firewall where we talk a lot about the gut epithelial cells, because crossing that barrier is a big event in terms of the gut and immunity. So again, it's sort of a little hint for you that these are the ways that these questions are going to be arranged. It's not about just being able to memorize and regurgitate. It's about knowing it, being able to recall it, and then being able to apply it. So if you know what factors are normally are being produced, and you know that you see something going down, which one might it be from a list given to you? Any other questions? Yes, Christine.
Is there office hour during reading?
Yes, there is office hours during reading week. I'm around, so. Any other questions that you guys have? Yes.
The diagram showing the diversity of the gut,
Yes.
we just have to know that it becomes more as we go down.
Hmm. You don't like memorizing all the different types of bacteria on the left side of the diagram? No. You'd rather memorize all the numbers on the right? Because I don't want you to do either, really. No, you don't have to. You don't have to memorize the different bacteria that you find in different sections of the GI tract. Is that clear enough for you? Yep. Don't have to know it. But if there are other places where we talked about different bacteria that grow in the gut, then yes. If you go back to the diagram that we have related to the early developmental colonization, then that diagram, yes, the bacteria you do have to know. Any other questions? If it's really quick, I have to make my way up to HMB.
So just the DEXA scan and MRI. I know like you've shown us, but I just feel like they look a lot like really similar.
They're not. They're not. They're really not. So DEXA scan uses X-rays. An MRI actually produces a magnetic field along the RO plane. So there's a magnetic field that's put this way, and what it does is it creates a radio frequency pulse. That thing that spins around you creates a little radio frequency pulse that takes some of the protons in your tissue and puts them into a higher spin state. And then once that scanner has passed by, it goes back to a lower spin state, and some of that energy is released. It's not the same at all like an X-ray, which is literally just X-rays passing through, and we detect it in two different planes. So they're not the same. They tell you very different information. Although I glossed over it, the information that you get is quite different. Any other questions? You'll have to wait until third year. You'll get that in more detail. That's all I can say. Any other questions So hopefully that will maybe either panic you more or put your mind at ease a little bit more, or at least give you an idea of how you should start studying a little bit more in terms of getting started or focusing. Okay. Anything else? No? Thanks for dropping in. See, you should have all stayed at home because, well, except for you two. Because you didn't have any questions in person. I am here, so you can ask during. All right, I'll talk to you one more time before your midterm on Monday anyway. So.